Let's continue with the bottom half of our notes, where they've given us two shapes, a rectangular prism and a cylinder, for us to find the surface area of. Let us begin with the rectangular prism. Now, zooming in, I can see that they've given us three different measurements for this rectangular prism. They've given us a length of 4 centimeters, a width of 6 centimeters, and a height of 5 centimeters. Those three dimensions are going to come into play when we try and figure out the surface area of this rectangular prism. Now, in order to find the surface area, we're going to find the area of each one of the sides for this prism and just add them all up together, like it says here. So, let's start naming some sides. The first side I see is the front, which I've highlighted in red. Now, the problem with this picture is I can only see 3 of the sides. But I know that if this rectangular prism has a front, it must have a back. The other side I can see is the top. And if there's a top, there must be a bottom. Finally, I can see that we have a right side, which I've put in orange, which must mean there is a left side behind the rectangular prism. So I've got my 3 different sides. I've got my 6 different sides. Let's see if I can find some areas. Well, the first one I see is this front, and I need 2 measurements for the front. I see we've got length, which I'm going to put for L, and then this side, which doesn't have a measurement, but I see that it lines up with the height. So I'm going to put in H. L times H, and that's going to be the area of my front. Now a little shortcut I'm going to take is that I know the area of the back is the same as the area of the front. So that's also going to be L times H. Now on for the top and bottom. The top's 2 measurements are going to be the length, which lines up very nicely there. But then instead of the height, we're going to use the width, which lines up with our green side right there. So we've got length times width and length times width. Finally, we can do our right side, which is probably the easiest. I see it has a width times height. And the same must be true for our left side. Now that I've got all these written out, I can turn them into a handy-dandy formula. The surface of a rectangular prism is going to be equal to the area of all these sides added up. But once again, I'm going to take a shortcut. I see that I have 2 length times height. So instead of writing them both out, I'm just going to write 2 times length times height. I'm going to do the same thing for my top and bottom by writing 2 times length times width. And finally, I will do the same for right and left. 2 times width times height. So instead of 6 individual sides, I've actually got 3 pairs of 2 sides. 1, 2, 3. All that's left to do is plug in the numbers they gave me into my formula. So my length, or L, is going to be 4 centimeters. My height, or H, is going to be 5 centimeters. And my width, or W, is going to be 6 centimeters. Now with some simple multiplication, I can get that 40 plus 48 plus 60 is equal to our surface area, which means that our surface area must be equal to 148. Now, with the cylinder, we're going to follow pretty much the same thing. We're going to figure out the area of all the different sides and add them up. Once again, the easiest sides are the top and the bottom, which are two circles. Hopefully you remember from 6th grade, but if not, that's okay. The area of a circle is pi times the radius of the circle, which is half the distance across, squared. We've got two of these, and then finally, our rectangular midsection. If you've forgotten what shape that midsection is, you can always look up here at our net, which has cut it in half and laid it down. Now, normally the area of a rectangle is length times width. Our rectangle is a little different though, for a couple reasons. One, it's turned on its side. So instead of width, we're going to have an h for height. Now let's talk about the length of this rectangle. We can trace from one corner all the way around and get back to the same place, which means that our rectangle has the same length as the outside of this circle. Well, the outside of a circle I know is called a circumference, and it is found using the formula 2 times pi times r, where r is radius again. So instead of length, I'm going to substitute that in, 2 pi r, to make it a little easier on myself. This gives me another handy-dandy formula that I can use for the surface area of cylinders. Two circles, which is 2 times pi r squared, plus the area of the rectangle, which was length times width, but we rewrote it as 2 pi r times h. Again, with this handy-dandy formula, all I have to do is plug in the numbers. My h stands for my height, so I know that's going to be 6. But whoever wrote this problem tried to play a trick on us. Instead of giving us the radius, which is just halfway across the circle, they gave us the whole diameter, which is all the way across. But that's okay, because I can find the radius by dividing the diameter in 2. This gives me a radius of 6.5, or 6.5, which I can plug in for r in this formula. The last thing I need to fill in is my height, but I already know that because of the picture, that my height is just 6. I can then use a calculator to do this multiplication and addition to get my final surface area, which is going to be equal to 490.4. That's it for these notes. If you have any questions, please check with your teacher.